Hi, my name is Tommy, and this is you, and we're here to talk about the project that we worked on last year. This is going to get a bit technical, so please bear with us. So, who is Logic Interactive? We're based in Oslo, working with exhibits, interactive installations, VR and AR solutions, and much more. We work a lot for science centers, museums, and other public spaces, among other things. Now, this is what we want to talk about. Glava VR. It is what we could call a location-based multiplayer edutainment experience. It was a fun and somewhat challenging project we worked on last year during a short time frame of approximately 6 months. So this is the core team that worked on the project. In addition, we also had a great sound designer, Einar Stabenfeldt. So, who is the client? It's the Norwegian Glava Group, owned by and with direct support from Svensson. Svensson is a very big international company with over 170,000 employees and a turnover of 466 billion Norwegian kroner. Glava has 500 employees and a turnover of 2.4 billion kroner. So, why does a project company making isolation and materials for construction want to build a VR experience? Well, as it turned out, the mother company, Svensson, had opened a high-tech visitor center in Paris. And here in Norway, they were looking to do the same for clients and partners, but also for school and school classes. So the concept we had was to make a fully fledged location-based virtual reality experience located at the client's factory where we were building for them in Askim. Just in case some of you are unfamiliar with the concept of location-based virtual reality, it means the virtual space is anchored to and should match the real-world space one-to-one. All things present in the real world must have a counterpart in VR. If you touch something in real life, it should be there in VR too. And this is some early concepts that we did. There is a stage for VR, a tracking solution, a spectator screen, and a gear up and down station. And this is the finally realized project. Turned out pretty similar to what we had planned. So, how to achieve this? Well, we had some challenges. What's the best way to do it? We have never made a LBVR setup before. We need to research a lot. We need to make it happen fast. And we have a small team. And it has to be wireless, and it has to have full body tracking. And we have to make it fun. We used Unreal Engine, which is a great engine for a project like this. To get good tracking, we teamed up with OptiTrack and Target 3D from London. They really helped us to get good results. Setup resulted in a pretty high-end OptiTrack solution using over 26 cameras, HMD trackers, and over 30 tracking bodies, all streamed to VR in real time. And this shows our final player rig. It includes the VR backpack, HMD, in-game tool prop, and 6-point body tracking to solve inverse kinematics in real time. This shows our VR scene at the visitor center. It's around 40 square meters in size. A fun fact, we actually had to design a grid system to keep the players from crashing into the walls. On the hardware side, we wanted to go with the latest unreleased VR backpack from HP at the time, the HP VRZ G2. It was very difficult to get a hold of because it wasn't released yet. And this also ended up delaying the project, but because of the greatly improved performance, it was the right call. So now, we will have a look at some in-game screens to give you an idea of the general look and feel of the game in VR. The scenario takes place at a construction site, somewhere in Norway. And the first issue we had was to do with lighting. We didn't have time to do static light bakes, because of rapid development and iterations. So the solution was to do fully dynamic lights, Distance fill shadows and ambient occlusion can look pretty good in Unreal Engine. We also wanted to use lots of high detailed elements in the scene, and because the player's area is pretty limited, we could get away with controlling the level of detail pretty good. The client was also clear that it had to be a Norwegian setting with a living, detailed environment. So, in the experience, you're guided through it all with a VR guide. She's a kind of a goofy construction robot that tells you what to do, and she tries to be funny. This is a view from within the VR game. The guide talks about HMS safety and then almost falls over the edge. It's really kind of silly. We had to do quite a bit of motion capture performance for all of this, and we were really pressed on time. So we set up an easy-to-work with motion capture pipeline that gave us fast real-time integration from our live actor directly into Unreal Engine and VR. And then I'm going to give the word over to you.
Hey, sorry. So going into this project, we knew this was a multiplayer location-based VR experience. None of us had done that before, so it was quite a challenge ahead of us. So the technical requirements were that we had to synchronize the game world and the game state at real time and stream live mocap data of players to the backpacks. I also had to stream the position and rotation of physical props to the backpacks as well as the server, and we also detect triggers and activate devices around the room. So the final network setup that we built looked something like this. So we had 2 servers, one game server that ran the Unreal Engine game, as well as 4 backpacks that ran the client side of the Unreal game. In addition to that, we had the OptiTrack server that was connected to the 26 different OptiTrack cameras that were placed around the room. I also want to mention that we had connected the elevator and the fan directly to the game server, so it was controlled by that. In addition to that, we had 4 different kind of tools that were also wireless. I'm going to talk about in a bit. So yeah. So multiplayer game development. So location-based VR games are multiplayer, and multiplayer is hard. Luckily, Unreal Engine's multiplayer built-in networking is very good and let us get up and running quite fast. And knowing the capabilities of the hardware and the network we were going to run everything on was very helpful for us. When developing software, we could take a lot of shortcuts and could simplify a lot of things because of it. But still, multiplayer is hard. So we used, so one of the things that were special with this project is that we had to have these tools. We used OptiTrack for tracking the position and rotation in space of these tools. And in addition to that, we had to detect triggers. So whenever you press the button, the game could detect that you had pressed it. So we used an Arduino-like device that sent a signal over Wi-Fi that was charged by a rechargeable battery. We also created a plugin in Unreal that could detect the signal and use it to control what's happening in the game. And as you see, the final tool was actually made from a Kärcher gun, like a pressure gun, and we actually took the inside and replaced it with our own custom electronics. So as you see here, this is how it looks like in the game and in the real world. We only had one physical tool in the real world, of course, but in the game it turned into different things depending on which game you were on. So you can see, yeah. So one of the first problems we had to solve in the game was movement. as usual in VR. For us, we want as much one-to-one movement as possible, but we still need a way to kind of move around the stage or the level whilst being in place in the real world. So elevator was a very natural choice at a building site. So this is some shots from the elevator. So we built a physical elevator that matched the one in the game. So we spent a bit of time aligning the elevator so it matched the one in the real world. So whenever you touch the sides of the elevator, you also touch the sides kind of in VR. And also whenever you rode the elevator up and down, it actually vibrated because we had a motor inside. It kind of vibrates like a phone. So it feels like it's rumbling and moving. So so with the elevator you can travel to different stages. We had 3 different games at 3 different floor levels. On the ground floor, we had a plaster game, kind of, so where you're spraying these walls, and your score is determined by how well you sprayed, basically, like how much of the wall you had covered. So this is another shot from that. So on the mid, kind of in the center of the building, somewhere there is this isolation level. So you can see building workers running around working on the interior, and one thing we want to show was the effect on acoustics that different kind of isolation had. So there were balloons floating around the level that you had to pop with a dart gun, and you could hear the difference in the sound it makes. So this is a better picture of that. And finally, on the roof, you had a puzzle game. It's I think it's this picture shows. So it's basically like these roofing sheets that are pre-cut into different forms, and you had to try to place them in the correct location, so it forms a perfect grid. So I think I have to skip this one because we are out of time. So finally, we also have a future lab level where it's just for fun. Yes, thank you.